Yes, our final speaker this evening, or this morning, this evening, this afternoon, depending on where you are, is our alumni keynote speaker, Cristiano Pizzamiglio, who earned a master's degree in aerospace engineering from Politecnico University of Torino in 2015. From 2012 to 2018, he was a member of Team Diana, a student group dedicated to the development of planetary roller prototypes, where he focused on structural multibody dynamics analysis using software such as Patran, Nastran, Atoms, and MATLAB Simulink. As team leader from 2013 to 2015, he directed the development of the AMALIA 3.0 rover prototype. He is currently a biomechanics research manager at Innovis, a global US medical device company, where he leads an international team and has developed advanced systems for orthopedic prosthesis research and development, integrating machine learning, statistical shape modeling, and optimization techniques. Now, Cristiano is currently in the air and unable to present live, so he has recorded his talk for us, which we will play here.
Good morning. Enrico and I are very glad to discuss with you the journey that we had as students in using the Hexagon software suite that as a not only give us the opportunity to grow from an engineering perspective, but also give us really the opportunity to also deepen those topics that we only had the opportunity to cover a lesson only from a theoretical perspective. Today, we would like to introduce you to the Team Diana. Team Diana, as you can read, is a space robotics group run by students at Politecnico di Torino. And the main goal of this team is to design and to manufacture wheel planetary rover prototypes. We do not only just design this rover, but also then we also have the opportunity to actually attend challenges that are run, for instance, in Poland, the so-called European Rover Challenge, where we actually had the opportunity to see our rover in action. Of course, the development and the engineering of those prototypes has been heavily driven by simulation software. And of course, we use a lot the Hexagon software suite, software like Atoms or Patran and Nastran have been very useful to understand, for instance, the structural strength of the components, or to understand like the dynamics of our vehicle, to understand, for instance, the dynamics of the robotic arms of the rover, and so on. And the most important thing that I really would like to highlight during this brief discussion is that this software were not only just useful, of course, for improving the design and of our vehicle, because of course this is the main point of using simulation software, by reducing cost, by reducing the number of iterations, by reducing the number of physical prototypes that we have to develop. So the point of simulation software is try to get to the final version of our rover as soon as possible, reducing as much as possible those iterations that of course are costly. But the role that simulation had for us was also the opportunity, the educational opportunity, right? To learn to apply all the theory that we learned during attending classes, and to actually apply them. And also really interesting the fact that we also had the opportunity to share like this this knowledge between team members. So for instance, the more senior team members also had the opportunity to teach and to transfer their knowledge on how to use the software, how to use the software in an effective way to the junior members, in order to understand how to use the software and how to actually use the software for the development, for improving the development of our rover. So you can see on the left hand side we have different rover that we have developed throughout the years. But let's go to the simulation software. For instance, here in these slides, I would like to show you a video of a simulation of the AMALIA rover. AMALIA is one of the first rover that we have developed. It was like in the 2010s. And here, as you can see, we perform a co-simulation. So we were using Adams for the multi-body dynamic model, and we use Simulink for the development of the control system of an active suspension system. So as you can see here in the video, on the portion of the video at the top, we have the active suspension system. So as you can see, the chassis of the rover is horizontal with respect to the ground, while in the lower portion of the video, we have the passive suspension, the passive suspension system. And so that was really useful for us because it allowed us to have a vehicle which is like stabilized on an even terrain. Another example that I would like to show you is again the co-simulation that I just mentioned. But here also we added component from the machinery module that is available in Adam. So in this case, the gears and all the other components were not just like models like cylinder and spheres, but we actually used the real components from the Adam's machinery model. Of course, here the computational cost was higher, but at the same time we get a lot more we get a lot more details, a lot more information on the design of the active suspension system. Another interesting example is the so-called Toro rover. This is a prototype that we have developed in 2018. And as you can see, this rover is much more complicated because it has, of course, the mobility system, but also features a robotic arm. And here we use a lot of the tools that Adams provides, like for instance, the possibility to model flexible component, also the possibility to model soft soil, and to model real wheels with real rubber. So as you can see here, we have the rover moving on an uneven terrain, using the wheels coming from the tire module. And as you can see here, we have the rover now also starting to move on a soft soil. Also here, it was of course more computationally expensive, but it was really useful to understand, for instance, the sinkage of the rover. And here also we have also simulated the operation of the robotic arm. So for instance, you can see here we have the robotic arm, which is like grasping an object. And here, for instance, there is another task where the rover has to, with its robotic arm, has to rotate a knob. Another example that I would like to show you, this really super interesting topic here, where we had the opportunity to do a simulation between Adams and another software for discrete element modeling. So as you can see, again, we have the Toro rover, and in this case, we are basically modeling the motion of the rover on a subsoil that was modeled using discrete component, and also using flexible wheels. At that time, it was not possible to use the Adam Flex module with the discrete element simulation. So in this case, the wheel was simulated as a collection of multiple bodies and torsional spring and translational spring. So that allow us to model the flexibility of the wheel. So as you can see, I mean, we use a lot. I mean, when I was a student, I definitely used a lot of this tool to improve the design of our rovers. Team Diana is still going strong, stronger than ever, also here in 2025. And with me, we also have Enrico Sabatini. And Enrico, I think if you would like to say something about the incredible results that you achieved this year and about your journey with the simulation software.
Yes. So thank you very much, Cristiano, for the opportunity. As he said, I'm happy to confirm that after 15 years, we are still using the same softwares and the same techniques to develop our rovers. I think that after Cristiano left, we did ARDITO, which was a project that was 5 years long. And ARDITO was a really big rover, fully aluminum with spring steel wheels. So for that rover, all the simulation was really important. And on the screen here, you can see the latest rover, which is Fortuna. This rover especially, I think that all the simulation package that Hexagon offers was really important because it allowed us to do the rover, to design and build the rover in only 8 months. So in 8 months, we started the design, we did all the simulation, and that allowed us to do just one route of production. Everything fitted, everything was right, and then we brought the rover to the competition. We brought it to the European Rover Challenge, which is a competition in Poland. It's 6 or 7 years that we go to this competition by now. And this year, I'm happy to say that we achieved the best results that the team has ever achieved, of 4th place from more than 100 teams overall. So it's a great achievement, and it's thanks to the hard work of everybody in the team. We use simulation tools, Hexagon tools, in the same way that you used them 10 years ago. So we mainly use Adams for multi-body simulations, mostly of the mobility system and the differential system, Patran, Nastran, through structural analysis, and then we are starting to use from 1 to 2 years up to today Apex Generative, and to design all structures that can only be done through additive manufacturing. So it's a step up that we did in the past years, and we are just now starting to produce metal structures through additive manufacturing.
Thank you so much, Enrico, and thank you so much for the audience. I hope you enjoy our presentation. Thank you.
Thank you.